Hello. So it was really good to see you all last week. I hope that if you weren't up to date, you've gone away and caught up. In the meantime, though, here are some starter questions on things that you should be able to do. So press pause now. Actually, not quite now. Now they're all on the screen. So press pause now and give those a go. Right, if you've done those, there are your answers, so you can check them. Oh, there's the answers to question 1. Hopefully that all fits on. If you've done all that right, that is for you, that's the end of this video and you can move on to the next thing. If you haven't done them right, it's really important that you go over them now, especially these bottom ones, because that's what we're going to carry on with and build on in this lesson. So if you haven't done them right, carry on watching because I'll go over them, but you really need to be good with these bottom questions. Right, so question 1 said differentiate, you see that? Differentiate 7x squared plus 3 all to the power of 5. This is, oh, see, there we go. So this is a chain rule question. So we've got something to the power of 5. So you differentiate the something, so you get 5 of those things to the power of 4. And then you also have to differentiate the inside as the compensation. So if you differentiate 7x squared, you get 14x. So my final answer for this one, and I'm going to go along the page just so I can get more on. My final answer for this one is 5 times 14, which is 70x. And then 7x squared plus 3 to the power of 4. So that's everything for question 1. For question 2, we had sine 6x. So remember, for this question, this type of question, this is my something. So I've got sine something. If you differentiate that, you get cos something. But it's not a something, it's a 6x, so you also have to differentiate that. And if I differentiate 6x, I get 6. So my final answer is 6 cos 6x. You do not have to have that bracket there. Part C is cos squared 4x. So remember, when I think of cos squared 4x, what that actually means is cos 4x squared. Okay, so that helps you identify which is the first function. So, excuse me, I've got something squared. So if I differentiate that, cos differentiates to minus sine. No, sorry. I'm getting ahead of myself. I've got something squared. If you differentiate something squared, you get 2 somethings to the power of 1. But it's not a something, it's a cos 4x, so you also have to differentiate that using the chain rule just like you did above. So I'm going to be using the chain rule for this middle bit here as well. If I differentiate cos something, I get minus sine something, but this time my something is the little 4x in the middle, and then we also have to differentiate this, and if you differentiate 4x, you get 4. So all together, I've got 2 times negative times 4, so minus 8 of the big brackets, which is cos 4x, to the power of 1, times by sine 4x. And then I don't need this power of 1 here, so my answer is, excuse me, minus 8 cos 4x sine 4x. Okay. Right, question 2. So this is right back to the trig we did ages ago now. So I've got 2 cos squared x plus 7 sine x minus 5 equals 0 in the range minus pi to 2 pi, which straight away tells us that we need to be doing anything that we're looking at in radians. So first of all, this is a quadratic, except we can't solve it yet because we've got cos terms and sine terms. So we need to use our identity that sine squared plus cos squared is 1, which we can rearrange to cos squared equals 1 minus sine squared. And that's what I'm going to substitute in here. Okay, so cos squared x becomes 1 minus sine squared x. So I've got two lots of 1 minus sine squared x plus 7 sine x minus 5 equals 0. If I multiply all of that out, I've got 2 minus 2 sine squared x plus 7 sine x minus 5 equals 0. So I'm going to simplify this, and I'm also going to times it by -1 as I go along, because I don't really want to factorise with a negative squared term. So if I times this by -1, I get 2 sine squared x. If I times this by -1, I get -7 sine x. And here I've got 2 take away 5, which is -3. If I times that by -1, I get 3. This will factorise to 2 sine x and sine x. And then to get +3 in the negative here, I need to have 2 negatives. And the 3 will have to be on that one, which means that sine x is 1/2 and sine x is 3. So you know that the sine curve only goes between 1 and -1, so this one's not valid. So you're not going to get any solutions for that. But you are going to get solutions from here, and we are in radians. Oopsie. There you go, we're in radians. So, oopsie. I want to be in radians. So if we inverse sine 1/2, get pi over 6. Remember, for sine, you get your second solution by doing pi, or 180 if you're in degrees, minus the first one. So pi minus pi over 6 will be 5 pi over 6. And if I think about my sine curve, so I'm in the range minus pi to 2 pi. So like that. I've got one solution here at pi over 6. One solution here at 5 pi over 6. I know that there aren't any more solutions in the range here, and there aren't any more solutions in the range here. So I actually don't need to add or subtract 2 pi, just by thinking about what happens with the graph. So that's that one. Question 3. So question 3 says solve in the range 0 to 360. So we're in 0 to 360. Sec x equals 3.5. I'm going to change that to sec x equals 7 over 2, because sec is a reciprocal function, so it's going to be nicer if we're in fractions. So we know that sec, you look at the third letter, is 1 over cos. So I can rewrite sec as 1 over cos. And then if I reciprocal both sides, so the reciprocal of 1 over cos is cos, the reciprocal of 7 over 2 is 2/7. And then on your calculator, you just need to arc cos that, inverse cos that. Need to be in degrees. So inverse cos 2/7. I get 73.4. Remember, your second solution for cos is the negative version of the first one, and then you add 360 to both, which will give me 286.6. In my answer, this one is out of the range. I had to have it to give me that one, but it's not in the range. So my answer is x equals 73.4 and 286.6. So they're the only ones that form the answer. The second one says 2 cot x equals 1. So 2 cot x equals 1. So I'm going to rearrange that to cot x equals a half by dividing both sides by 2. Cot is the reciprocal of tan. So if I reciprocal both sides, I know that tan x equals 2. By inverse tan 2, I get x equals 63.4. And remember, for your tan graph, you just find your other solutions by adding or subtracting 180 to the first one. So 243.4. That's everything in the range for those. And the last one is cosec 3x equals 11. So for this one, I want you to remember that because I've got a multiple or an adjustment of the value of x in here, I need to adjust my range. Oh, I'm sorry. I've just realised I've had thetas and x's mixed up. Sorry. Let's change that to an x, then it will all be okay. So my original range is 0 to 360 for x. I've got 3x, so the range I'm going to be looking at for my 3x is 0 to 1080 by timesing everything by 3. Right, so cosec is the reciprocal of sine, so I know that 1 over sine 3x is 11. If I reciprocal both sides, I know that sine 3x is 1/11. So at this point, you can inverse sine both sides, which gives me 5.2. Remember, for your sine curve, you get the next one by doing 180 minus the first one. So 174. And then for all, oh, sorry, that's 3x there, apologies. For all the others, I need to add 360 to all of those. So 5.2 plus equals 365.2. 75.2. Sorry, I've just realised this is scrappy paper here. Then 174.8 plus 360. 534. And then add 360 again. 894. And that'll be all I can get in the range. But that's for 3x. So then to find your final answers, you need to divide each of these individual terms by 3. So 5.2 divided by 3. 1.7. 174.8 divided by 3. It's 58.3. And so on. Divide each of those by 3 to get the rest of your answers in the range. There you go, that's your starter.